Welcome to Study Loop.
In this problem on the topic of waves and sound, we are given the tension in a string and its linear density. We are then told that a wave on the string travels in the minus x direction with a given amplitude and frequency. We want to calculate the speed of the wave as well as its wavelength, and then write down a mathematical expression for the wave. So we know that the speed of the wave on a string is given by the following equation. The speed v is equal to the square root of the tension of the string divided by the mass per unit length of the string. And this is equal to the square root of, we are given these values, so the tension, we won't call it T, we'll call it F. So the tension F over the mass per unit length. The tension is given to be 15 newtons and the mass per unit length 0.85 kilograms per meter for the linear density. Calculating, we get the speed of the wave on the string to be 4.2 meters per second. Next, we want to calculate the wavelength of this wave. Now we know the wavelength lambda is defined as the speed of the wave divided by its frequency. And again, we know both these values. The speed of the wave we calculated to be 4.2 meters per second, and its frequency is given to be 12 hertz, which means if we calculate this, we get the wavelength of this wave to be 0.35 meters. Now finally, we want to write a mathematical expression for this wave. We know the amplitude, and we know that the wave is moving in the minus x direction. So a general form of the wave is y is equal to the amplitude a times the sine of 2 pi times the frequency f times t, and the wave is moving in the minus x direction, so it's plus 2 pi x over lambda, and we can now substitute our values for a, f, and lambda. So this becomes the amplitude, which is given as 3.6 times 10 to the minus 2 in meters, multiplied by the sine of 2 pi times the frequency of 12 hertz, multiplied by t, plus 2 pi x divided by the wavelength, which we calculated to be 0.35 meters. And so we can simplify this and write this as 3.6 times 10 to the minus 2 meters times the sine of 75 radians per second times t, which is 2 pi times 12 hertz, plus 18 per meter multiplied by x. And there we have a mathematical expression for the displacement of the wave y.